Hey students, in this video we're going to cover verifying identities. We're going to start with deriving the Pythagorean identities. So from algebra and geometry, you might remember that the equation of a circle is x squared plus y squared equals, of the unit circle is going to be x squared plus y squared equals 1. In general, for a circle, is going to be x squared plus y squared equals r squared. And since on the unit circle, the x coordinate is cosine theta and the y coordinate is sine theta, we can replace those in this formula to get cosine squared theta plus sine squared theta equals 1. This is the most important fundamental Pythagorean identity. So we're going to use this one a lot. This is important if you take calculus after this. You're going to use this. So from this identity, the other two Pythagorean identities are developed. So these are the primary identities that we have right here. We just discussed sine squared plus cosine squared equals 1. To get the middle identity, all we did is divide by cosine squared theta. So sine squared divided by cosine squared is going to be tangent squared. Cosine squared divided by cosine squared is going to be 1. And 1 divided by cosine squared is going to be secant squared. That is how we get this middle identity. The bottom row we get by dividing by sine squared theta. And so a sine squared divided by sine squared is going to give us 1. Cosine squared divided by sine squared is going to give us cotangent squared. And 1 divided by cosecant squared is going to give, 1 divided by sine squared is going to give us cosecant squared. So these are in the first column, we have the 3 primary identities. Their 2 alternate versions are in the middle and on the right in case you need to manipulate those for verifying an identity. And so when we are verifying a trig identity, what we want to do is generally you want to work the more complicated side. If necessary, I recommend turning everything into sines and cosines, especially if the side of the identity that you're working with only contains sines and cosines. Anytime you see addition or subtraction of fractions on one side of the denominator, that is an indicator that you need to use an LCD, followed by probably applying a Pythagorean identity. And don't forget things like doing difference of squares to factor. And if all else fails, do not be afraid to start over a identity. All right, so I'm going to work this in my notes app because I have more room. If you want to follow along, the slides in the order that we're going to work these, there are 5 identities, and we're just going to start with identity 1. All right, so jump over to notes. All right, so the first one that we have to verify is tangent theta equals sine theta times secant theta. So the sine theta secant theta is the more complicated side, so I would say it's smarter to work with that side. The side that we don't work with, we're just going to bring down each step or put some quotes to reference that thing. So the first thing that we can do with sine theta, so let's get some stuff that we know. So we know tangent theta is sine theta divided by cosine theta, and we're going to we also know that cotangent theta is cosine theta divided by sine theta. We want to remember that. So now on the right side we have sine theta times secant theta. So we can turn, if we can get sine over cosine, then we can get tangent. So we know secant theta is 1 divided by cosine theta. And the way we multiply fractions is we multiply straight across. So we would have sine theta times 1, which is sine, and 1 times cosine theta, which is cosine theta. So on the left side, we keep our tangent theta, and finally we're going to get tangent theta equals tangent theta. So that is how we prove that identity. Now on the left side, we did not do anything. We just brought a tangent down for each step because to verify an identity, you only work with one side. You don't move anything from the left to the right or the right to the left. The second identity that we have is secant theta minus tangent theta times secant theta plus tangent theta. That should say equals 1. And so here we're going to do what we would do in algebra, which is just distribute. So we're going to have, I'm at the top of this note apparently. So we're going to have secant times secant, which is secant squared theta, not secant theta squared, because the trig function itself is squared. So we get secant squared theta minus secant theta times tangent theta. I'm sorry, that should be a plus because we're doing this. And then we're going to have negative tangent theta, secant theta, and then negative tangent theta times tangent theta is going to be negative tangent squared theta. And that supposedly is equal to 1. So this term and that term, they cancel because one is positive and one is negative. So we get secant squared theta minus tangent squared theta equals 1. Now, if we go back over, let me close down some of this nonsense I got open. If we go back over to our PowerPoint, one of the Pythagorean identities we have is 1 is equal to secant squared theta minus tangent squared. So we're going to use that. So secant squared minus tangent squared, that's 1. So we end up with 1 equals 1. We'll put an exclamation mark because we did it. All right, so far, not anything too algebra intensive, not intensive. That's not a word. Not anything that is crazy. Next is we have secant theta divided by 1 minus tangent theta equals 1 over cosine theta minus sine theta. So I would say we work with this side. And since on the right side, everything is in terms of sine and cosine, I would recommend turning everything on the left into sine and cosine. So secant theta is 1 over cosine theta. And then we're going to have 1 minus sine theta over cosine theta. So we have a fraction within a fraction. So now, anytime you have a fraction within a fraction, you want to first get common denominators in numerators and denominators. So what we're going to do is leave the numerator of this fraction alone. We're going to still leave that as 1 over cosine theta. And then we're going to divide by, so if this is just 1 over 1, what we're going to do is multiply by cosine theta in the numerator and multiply by cosine theta in the denominator. So what we get is cosine theta minus sine theta all divided by cosine theta. Now, you know when you have a fraction, and this is still going to equal that value. I just don't want to write it over, so we're going to just put some quotes. And these open and closed quotes means that we're still referencing what's on the right side. So anytime we divide by a fraction, we can multiply by the reciprocal. Oh, get out of here. So we're going to have 1 over cosine theta times cosine theta divided by, cosine theta divided by cosine theta minus sine theta. Anytime we divide by a fraction, multiply by the reciprocal. And so the cosine thetas will cancel, and we end up with 1 over cosine theta minus sine theta. And that is exactly what we were trying to verify. So the trick on this one was, because everything was in terms of cosine and sine on the right, we turned everything into cosine and sine on the left. And just by applying some fundamental algebra steps, we ended up with the same thing on both sides. So that is how we work that one. The next one we have is cosine. Did I do this one? Nope. All right. So now this is going to be a trickier one. We have sine theta and cosine, sine theta plus cosine theta on the right, and a lot of stuff on the left. So again, anytime that one side is in terms of just sine and cosine, I would make the other side also be in terms of sine and cosine. So on the right, on the left, I mean, all right, get out of here. We want to do cosine theta divided by 1 minus, remember tangent is sine theta over cosine theta, and then we're going to get plus, we're going to keep the sine theta in the numerator and divide by 1 minus cotangent theta is just going to be the reciprocal of tangent. So cosine theta divided by, I can turn this into S. All right, maybe I can't. We'll make that sine theta. Go back to your pen. So sine theta. All right, so let's do our steps in different colors so that we can see where we're actually making changes. So here, that's just going to equal the same thing. And so next, all right, so we're going to do the same trick of getting a common denominator. So that means that for this one, we're going to make this, so that's 1 over 1, right? So we're going to multiply by cosine theta over cosine theta. And for this one, we're going to multiply by sine theta over sine theta. That's how we're going to get our next step. So we're going to get cosine theta over cosine theta minus sine theta over cosine theta. That's what we get for this first fraction. For the next one, we're going to get plus sine theta divided by sine theta minus cosine theta divided by sine theta. And if we are, so the next step that we want, that's going to equal the same thing. And the next step is going to be to, I would say, divide by the reciprocal, multiply by the reciprocal of these things so that we get, we're going to have cosine theta times cosine theta over cosine theta minus sine theta. And then we would have plus, so we make this a whole thing. So then we're going to have plus sine theta times sine theta over sine theta minus cosine theta. And when we simplify, this is all going to be one thing. We're going to get that equals the same thing. And let's change colors again. We haven't used green. So we're just going to get cosine squared theta divided by cosine theta minus sine theta plus sine squared theta divided by sine theta minus cosine theta. Now, some of this requires some tricks on our part. Now, I'll tell you that what's the difference in cosine theta minus sine theta as opposed to sine theta minus cosine theta. So the difference is, let's make some room up here. So if we factor out a negative from this thing, we would get negative. If we take out a negative, that's going to give us cosine theta minus sine theta. So that's our trick. is that these are basically the same thing. So we're going to have cosine squared theta over cosine theta minus sine theta. And so, again, we're taking out a -1. So that's going to be, I need my eraser. So actually, let's write that step so that we don't lose anything. So that's going to be minus, why did it go to that? So minus sine squared theta divided by cosine theta minus sine theta. Now, again, all we did was take out a negative to flip this thing around. We just took out a negative. And so now they have the same denominator. So we have cosine squared theta minus sine squared theta. And we're not going to worry about this right side up here. We know that we should get sine theta plus cosine theta. So let's keep going. So cosine squared theta minus sine squared theta over cosine theta minus sine theta. And if we take another step, now remember a difference of perfect squares. If you have a squared minus b squared, that's going to equal a minus b times a plus b. And that's what we have in the numerator. So we're going to make that cosine theta minus sine theta times cosine theta plus sine theta. And remember, we were dividing by cosine theta minus sine theta. And so we can just cancel those two things out. And what we have left over is what we were trying to prove way up at the top. Sine theta plus cosine theta. All right, so the steps for this, again, were we first turned everything into sine and cosine. And then we just did a bunch of algebra. We got common denominators. We multiplied by the reciprocals of fractions. We got a common denominator cleverly by factoring out a negative. And then that allowed us to use a difference of perfect squares. And so the last one is cosine theta minus secant theta equals negative tangent theta sine theta. So for this one, I would recommend still working with, I actually don't think it matters which side you choose. Let's choose the left side. So we're going to turn secant into 1 over cosine. So we're going to get cosine theta minus 1 over cosine theta equals the negative tangent theta sine theta. So next, let's change colors. So now we're going to get a common denominator, right? So remember, that's over 1. So we can multiply by cosine theta in the numerator and cosine theta in the denominator. So we get cosine squared theta minus 1. And since now they have the same denominator, we can say that's over cosine theta. And that's still going to equal this negative tangent theta sine theta. So let's go back to our PowerPoint for a moment. So look here, cosine squared is 1 minus sine squared. Cosine squared is 1 minus sine squared. So let's see if that's going to be useful. So cosine squared is 1 minus sine squared. Okay, so we're going to get 1 minus sine squared theta. That's the cosine squared that we're replacing. Different color, Mr. Martin. Different color. Let's go with blue. So we're going to say 1. Why did I chose the wrong thing? So 1 minus sine squared theta minus 1 divided by cosine theta is still going to equal that negative tangent theta sine theta. And, let's use white. So what's going to happen now is that the 1's cancel. So we get negative sine squared theta over cosine theta, and that still should equal the negative tangent theta sine theta. So anytime something is squared, it is basically multiplied by itself. Now, the reason we know to do this is we have two terms that we need to get on the right side. Down here, we only have one term. So how do we create two terms? Well, what we're going to do is just say negative sine squared is negative sine theta times sine theta, and that's divided by cosine theta. And so now this is the equivalent of having negative sine theta over cosine theta just times sine theta. Now remember, sine over cosine is tangent, so negative sine divided by cosine is just going to be negative tangent theta times sine theta, which is what we were trying to prove. So all the way back up here is going to be the thing that we were looking for. Negative tangent theta, sine theta. So that is our video on proving trig identities. My recommendation to you is to do lots of practice on these. The general steps are, again, work the more complicated side. When possible, turn everything into sine and cosine. And don't forget your algebra steps for getting common denominators and factoring. All right.